Okay, here is a mini lecture on things we're going to be doing together on Friday. The topic for this week is visual analysis of graphic data. There we go. So my agenda for this talk and for our time together on Friday is to first review standards for identifying evidence-based practices. The standards come largely from the Council for Exceptional Children, as well as individual authors who have discussed this topic quite a lot. The second topic for now is what are the criteria for choosing a single case research design? Or in other words, how do you choose an appropriate design for your research question? Third, I won't review the content that is in the IES visual analysis presentation, but we need to refer to these quality indicators, and I would like to spend time with you on Friday having you practice using them and looking at some single case design figures. So I'm going to mention that now. And then the last is I want to talk briefly about writing tasks, whether or not they're proposals that you're doing here in the seminar or whether you're writing for publication sometime in the future. Okay, now one thing I like to do is start with a warm-up. So I'm going to read these questions and I'd like to talk about them and hear what you have to say about these questions when we're together. The first question is, should special educators or psychologists only be using evidence-based practices? In other words, should evidence-based practices be what we use for everything? What do you think? Okay, so that's the first question. The next question is, how much of our curriculum, whether or not it's curriculum used here in Vietnam, it's in schools in America, how much of our curriculum is actually based on evidence-based practices? And I will share information about America, and I want to hear what you think about curriculum here in Vietnam. Third question is, would you, as a researcher or practitioner, or would you advise a teacher, would you implement an intervention that did not meet the standards for evidence-based practices, but did have promising results from 2 samples? Now, that third question is really a technical question, and I need to go to my next slide to talk about what I mean by samples. But when I review that slide and when we're together, I really want to think about what would be your personal standard for deciding whether or not to implement an intervention. So if it doesn't meet a standard as being designated an evidence-based practice, but there are results that are promising from 2 samples or 2 studies, that's the core question. But I need to go on and share with you the next slide. So the next slide shows part of a chart that's in a publication, and that's fine. I can share the entire resource with you, but I wanted to go to just sort of like the core that relates to this topic for right now. So the Council for Exceptional Children has come out with criteria for designating a practice as evidence-based. And you can do either A or B or C, or excuse me, I misspoke. You can do either A or B and C. So sorry about that. So let's talk about what are the standards. So it has to do with the studies, it has to do with the methodological quality of the studies, and it has to do with the fact that we're looking for positive outcomes. So I'm going to read what it says in A. An evidence-based practice must be supported by at least 2 methodologically sound group comparison studies with random assignment to groups and the unit of analysis aligned with unit of assignment, plus having positive effects, and at least 60 total participants across studies. To kind of just go to the big idea, 2 group studies, 60 participants, methodologically sound, and methodologically sound includes specification about random assignment and unit of analysis. Okay. Evidence-based practice must be supported by 4 methodologically sound group comparison studies with random assignment, but the unit of analysis is not aligned with the unit of assignment, or there's non-random assignment to groups, and there are at least 120 total participants. So what that means, the second bullet point, is basically saying you have 4 quasi-experimental studies where there's random assignment, but the unit of analysis is not the unit of assignment. That's a mouthful. That's very technical. We can talk about that more in person. The idea about random assignment is clear. Random assignment should technically be at the level of the teacher or school, and then also at the level of student. So, for example, you have 5 schools or 6 schools, you randomly assign half to one condition, half to another condition, and then you've got your teachers within schools assigned randomly to what you're doing. Now, unit of analysis is a topic that's come into the research community. It could be the last 15 years. It has been a while. It's not everywhere. So to kind of take that for a second, unit of analysis means if I look at the average scores of students who are learning with those teachers who are randomly assigned, and I just look at the student work and the averages, maybe each teacher, for the sake of a simple experiment, has 20 students or 40 students. They have some number of students. The teacher was randomly assigned, but if the student was not randomly assigned, it's quasi-experimental. If the student was randomly assigned, it is experimental. But the unit of assignment should not be analyzed at the student level if you are looking at averages within the entire class. Now, I'm really don't want to get bogged down here on that, but it's a big deal. So technically, you've got 2 studies that are really great, random assignment, and the unit of analysis is appropriate, or you have 4 studies that are really good, but they don't do the unit of analysis correctly. We see from the first to the second bullet point that there are twice as many participants that are being expected. So basically, you need to have more studies with more people if your design is not as good. That's the be-all. The third option, which relates to the seminar that we're doing together, is 5 methodologically sound single subject studies with positive results and at least 20 total participants across studies. So A would be the best. You have one of those criteria, the first, second, or third bullet point. I don't know that I need to read the rest of the slide. Basically, we're going to get to looser criteria with more participants. So I think I'm going to move on, but I'd be happy to talk about this more together next Friday. Okay, now I've kind of alluded to this and it's mentioned in the IES video, but before you do visual analysis, you need to know, did the researcher choose an appropriate research design? There's an appendix, it's a handout, it's in our Google Drive. I'm going to just show a couple of parts of it here. It's 13.1. So the first question to ask is your research question a demonstration question. In other words, you're comparing what happens in the intervention to what happened in baseline. Or is your research question a comparison question? For example, you're comparing two interventions. So that's the first thing. The second thing is your primary dependent variable of interest reversible? And what that means is it will reverse to baseline if you withdraw the intervention. Or is your dependent variable non-reversible? In other words, once the participant learns it, they will perform it accurately even in the absence of an intervention. I like to think about non-reversible as things that are academic, because presumably once you learn to read, you're not going to not be able to read. I suppose that might not be 100% true, depending on a context or a child or an adult, but basically reversible means you are not learning, and it's just something that's more likely to be a behavior. So we have to keep in mind both answers: demonstration or comparison, reversible or non-reversible. So continuing on with the appendix, it's listing on the left the design. So it's also, I should point out, the heading is if we have a reversible behavior. Basically, this chart is saying use ABAB in most situations if it's reversible, okay? And you're interested in a demonstration question. So ABAB is good, except we're going to avoid it if the participants, the implementers, stakeholders find that withdrawing the intervention is unacceptable. Okay, so I could think of a situation where, let's say, a child is doing something which would result in injury to the child or someone else, then we might not want an ABAB where we withdraw an intervention. Okay, so that's the first criteria. Use ABAB in most situations unless withdrawing it is not acceptable. So then the next is use multiple baseline. So multiple baseline, you're going to use as your next go-to type of a design. It's also helpful to use multiple baseline. It says here that instability threats are more likely than testing threats. And to put that into kind of like more common language, if you're not worried that exposure to whatever prompt you're giving is going to affect things, like in other words, you're not worried about a practice effect, or you're not worried about the participant being frustrated by being asked to do things over and over again in baseline, you would use a multiple baseline design. Okay, so multiple baseline is fine in that situation. But let's say you have a child or a teacher or a parent. Somebody is saying, why am I being asked to do X 10 times, 15 times, whatever the number of times is before we get to do the intervention? So then we're not going to do multiple baseline, which is basically where you have a probe maybe every single day, once a day, could even be 3 days, three times in one day, 3 times in the next day, depending on what we're talking about. If the repetition or the testing causes a threat, we're going to go to the third row, which is multiple probe. So again, we're saying ABAB is not feasible, and we're saying that there's something which for simplicity is referred to here as testing threats. I have not mentioned changing criterion design. I don't want to review that now, but we can talk about it more again together. But the changing criterion is basically used if you're applying something in a task analysis fashion, or there's multiple steps to doing whatever it is. So we'll talk about that more together. So reversible behaviors, we got it, ABAB, it's preferred, then multiple baseline, then multiple probe in multiple baseline. Okay, I'm almost done with this section. I know it's long. Non-reversible behaviors, we learned it, it's fine. What do we want to do? Multiple baseline or multiple probe. Okay, so that would be the options there. So when you read a research study, it's likely that because it's published, and especially if it's published in a decent journal, you as a reader can assume that they chose an appropriate design, because people who review the manuscript before it's published, there are usually 3, depending on the journal, sometimes 4 independent reviewers who are blind to the study but are expert in the content or in the design, and they'll determine that the design was appropriate. So usually you don't need to worry about critiquing a published article, but this information is just helpful because you're planning a study and it's good to know. Okay, moving on. So again, this slide is only showing the training that Rob Horner is doing on how to actually go through the steps for visual analysis. And I know they said it really well. They gave a great lecture, great examples. I'm counting on everyone knowing it so we can practice ourselves together after you're doing this. We'll do application. Okay. Assuming you're really comfortable with the analysis, there are some additional practical questions that you may face that I'm going to read here and we will talk about together. So the first question is, what should you do if data does not stabilize but continues in the desired direction in a condition? What should you do? Second question is it appropriate when measuring dangerous behaviors such as throwing, hitting, kicking, etc., to have only one baseline and one intervention condition? Is that appropriate? And the third question is, how do you find a balance between instruction for students and objectively determining the effectiveness of an intervention using single case methodology? So these are really questions that people have different answers to, and the answers may depend on the context. In fact, they most likely do. Okay, so that's for when we're together. And I'm going to go to a figure that's in chapter 8. So you have the entire chapter 8 in our Google Drive. This is one figure. It's figure 8.14, and I just copied it right here. It says, just looking at this chart, that on the x-axis, we're graphing sessions. So they're labeled 2, 4, 6, etc. But the tick marks are there for all of the sessions. It looks like I do see and know that there's going to be a break. Nope, sorry, misspoke. There's no break. There's no hash mark on one of the X's. So we have all the sessions through 22 sessions. We have 3 participants. The student on the top is Chris. In the middle is Pat. On the bottom is Danny. And okay, so I'm just kind of looking at the graph, and you may have a different order of how you're thinking about it, but what's being graphed on the outcome, the dependent measure, is the response per minute of something. Response per minute. Okay, so this is an early childhood setting. It looks like there are 2 dependent variables that are being graphed. One is with the triangles, and it says aggression for Chris. It says tantrums for Pat, and aggression for Danny. And then the second dependent variable says alternative response. which I assume would be described in the article and might potentially even be something different for each of the children, but again, is presumably just something that's appropriate. And that is graphed with the open circle. Okay, so that's the basic setup. I see that this was published in 2012 in the Journal of Applied Behavior Analysis. I think they discuss it briefly in the book. If anyone wants to see the full article, let me know. I will get it and put it in the Google Drive. But the question right now is about the visual analysis, and you've done that IES training. So on the next slide, I have 9 questions for you. I'm going to read them now. And again, I'm going to hope we can go through them and get your answers to them together. So number 1 is, what is the level at baseline? What is the level across phases? 2, what is the trend at baseline? What is the trend across phases? 3, what level of variability is present in the data? 4, is there a predictable and stable baseline pattern of data with 5 or more data points? 5, is there a predictable pattern, i.e. level and trend, of responding within each phase? Are there at least 5 data points per phase? 6, are the data comparable across adjacent and similar phases? 7, are there at least 3 demonstrations of an effect at different points in time? 8, does the change occur long after the intervention is introduced? And 9, does the change occur at different times in different phases? So if you see these questions, it aligns to slightly different wording, but aligns to the IES video. Okay, so hopefully we'll have answers that you can compare with each other as to what your answers are when we're together. Okay, now I'm going to move on, and depending on your level of enthusiasm for doing all this technical stuff, I have 3 more questions. We can maybe get to the end, what you think the answers are, and what I think the answers are too. So the first of these is, when conducting a formative analysis, and the word formative would have an implication of when you're really perhaps doing a functional behavior analysis. So formative is not necessarily for purposes of single case research design, as in, you know, you're ready with the intervention, but you're still tentative about what you're doing and what you're figuring out in terms of an intervention. So when conducting a formative analysis, what should we do if trend, variability, or level are uncertain, even after collecting 3 to 5 baseline data? Okay. Second question, is an intervention that solely affects the variability of an observable behavior valuable? And then continuing, what might be an example of a behavior that benefits from more consistent variability? So the second question is all about variability. The first question is about the length of baseline. The third question is, I'll be curious to see what you think about it, because it's been debated by scholars who do single case research design. And I'm wondering if you think that this would be open for a lot of debate or not. So that's my question, but let me read what it says here. Given that visual analysis is the principal means by which data from single subject studies are analyzed. Okay, let me say that again. Given that visual analysis is the way by which single subject studies or single case research design studies are analyzed, does the use of visual analysis make results more subject to individual interpretation? Are we going to be biased when we do visual analysis? Is it possible that following the rules that are shared in the video from IES and Rob Horner, is it possible that there would be subjectivity? So that's the third question, and it has been debated by researchers quite a lot. Okay, so that's a bit about design, a bit about analysis. Let's move on. The last part of what I want to talk about is to kind of speak more generally about writing and writing tasks. And there is a chapter, I didn't photocopy it, but we can figure out how to get it available if it's really something that people want, and it's all about writing. So the slide here is titled Writing a Final Report for Publication. However, when writing proposals and dissertation proposals, these would be the same kinds of expectations. So to go through them, there are different sections: the abstract, the introduction, the method, the results, and the discussion. The abstract in particular is written after the study is finished and after you write the rest of the sections. In fact, so you write the abstract last, and the abstract is a summary of the entire article. That's why, they take quite a long time to actually write. Oops, sorry, let me go back to a different slide. Go back there. Okay, so you got those different parts, and let's go through some of the details. So when writing the introduction, there are several approaches that people take. It's a little bit stylistic, a little bit the writer's preference. And there's a table that's in the book that give different approaches that are described. Sometimes, and so I put in my parentheses here, there's a logic model, and I'm going to show you one more, because if it's going to be in an article, it's definitely going to be in the introduction. Then you need to include information about participants. And we saw this with Golnozo's article, but these are the criteria or the elements that you would include when it comes to participants. So they include demographics, such as the age, maybe the cultural background of the child, maybe ethnicity. So demographics could also include socioeconomic status. That would be the first. You would have information about measures that you know. For example, IQ is one measure. There are multiple measures, and you just do the best you can with what's available to you, as well as knowing from your perspective what would be relevant for readers to see. What do you want the readers to know with respect to different measures and outcomes on those measures? And then the last is that you would have inclusion and or exclusion criteria. You would say the focus of the study was on children with ADHD who did not have any other disability, or you would say whatever was relevant to you. Okay, so you've got information about participants. The fourth bullet is got a lot of different things. We've talked about them together, so I'll just read them. The setting, procedures, materials, dependent variables that relate to your intervention, fidelity, social validity, the experimental design is also included. It's not part of the setting. I mean, these things are actually just part of the methods. I should have clarified. The data analytic plan and any information about reliability, such as reliability of observations in a fidelity sense, or reliability of observations for scoring. Okay, so all of the things in the fourth bullet, starting with the word setting, are part of the methods. Then with the results, it's going to really depend on your research questions. And the results are going to be qualitative if you're doing a qualitative study, or quantitative if you're doing a single case research design or an RCT. But the general information, because so much is open to what you're doing, is that the results would be in the order of the research questions. The last part for the report is your discussion. And in a good discussion, you first explain the relevance of your findings, whereas the results section, you just give the findings. In the discussion, you explain the relevance, but a good discussion goes farther and makes connections to other literature. For example, literature that you reviewed in your introduction. And finally, in the discussion, you suggest limitations to your design and implications, such as for future research or for practitioners. So the discussion is something which a lot of times, in my personal experience, the hardest thing to do, because in some ways you're being as philosophical and as theoretical as possible. Okay, I know this is very, very, very long. Let me go on and show you two pictures that we will talk about on Friday. This is something a colleague shared with me. It says, "U is a beautiful shape for your research article." So if you focus on the part in the middle, it's basically saying that when you begin the article, you're at a general level. In the middle of the article, you are more specific. And at the end of the article, you're more general again. And it walks through introduction, literature review, the body, the conclusion, and the discussion. And it says your goal for each part of this, each part of the article. Okay, so that's it for there. Very, very last slide is, I wanted to show one other example of a logic model. And this is from a figure in an article published in Learning Disability Quarterly in 2015. And rather than give you the entire article, let's just look at the logic model, because we were talking about that when we were together last. So first of all, I'm going to go to the top. The headings say the intervention component mediator, and then it says the proximal outcome, and then it says the distal outcome. And this aligns with last time when I said you start with the dependent measure. But in a sense, with these authors, they're saying we have two dependent measures. We have a long-term measure, or a measure that we hope will be affected ultimately, which is the student's mathematics achievement. And we are going to assume in this model by these people that we are going to improve students' overall mathematical achievement if we can improve their procedural fluency and their conceptual understanding. There are dependent measures in this article for each of the items that is shown here in either these bubbles or these rectangles. So these are just the names for the content. Well, I think, to me, based on what I know about teaching math and how children learn math, if kids understand the concepts and are relatively quick when they solve problems, they probably will improve their overall math ability, because we need both conceptual understanding and the ability to have procedural fluency, or to be productive, time efficient, those things. Okay, so the model, I'm going to go back to the part that's on the left. And in this context, they're talking about mediators. So mediators are variables that can be measured. In this case, it was statistically, and they're factored into the model. So they say that in terms of the intervention components, and I referred to them as core components previously, is whole number content. And there's two things there: operations and algebraic thinking, as well as number and operations in base 10, which as soon as I see that, I know these are young children. And the article does mention, I believe the kids are in kindergarten or first grade. So we have content, and then we have, I'm going to skip this part with these arrows for a second. We have validated principles of explicit and systematic instruction. So the teacher does demonstrations, number 1. 2, there are scaffolded instructional examples. 3, there are models of mathematical ideas. 4, guided and independent practice. 5, academic feedback. And 6, cumulative review. So those 6 steps basically are saying, do explicit systematic instruction when you're teaching the content that I just mentioned. So we have those things. We have the content, we have the methods of instruction, but we need the last part here, which is high quality teacher-student instructional interactions. So you need that piece of high quality when you're doing these things, because even if you have explicit instruction, what if someone is not doing it correctly? So all of this together, these things that are in the rectangles are all considered necessary, and there are measures of each of these things, and they affect the two proximal outcomes, which in turn affect the distal student outcome. And that's the logic model for the researchers. The first author is a fellow named Dobler, Chris Dobler, and that's their theory of change from implementation of the fusion intervention, that's the name of their kindergarten math curriculum, to increase student math achievement. So I hope that was, a good review or a good example actually of putting like a logic model, theoretical model into context so that you have even a better sense of the kinds of things that you want to think about with your proposals. So that's it. Thank you very much for listening. See everyone on Friday.